I'd like to say I'm really glad to spend some time with you. My name's Michael. I'm going to have the privilege of hosting today's webinar. Obviously, today's webinar is sponsored by Everon. It's regarding battery energy and storage defense, really helping prevent battery storage system fires before they even start. And what's really exciting about this topic is it's something that, quite frankly, is new and evolving. It's not uncommon for many of us to not really know, all there is to know about this particular topic because it is so new and evolving. In fact, when we were looking at the attendees for today's call, it was really great because it was reflective of a very diverse audience. Some of you have an interest in this topic, but could be in an adjacent industry, and that's really exciting. So today's topic is going to be a terrific opportunity for you to get involved. I do have one logistical point that I'd like to call out. It's how you can ask a question, how you can chat. I think we even have a couple of poll questions today. So if you're looking to do that, you'll probably see some buttons at the top of your screen. There's one that says chat. There's one that says Q&A. We'll reference these throughout today's interaction, but that's a way for you to go ahead and ask your questions in real time. We're going to be monitoring those, and we'll go ahead and collate those to have a robust Q&A session at the end. But feel free to ask those throughout. And whenever you see a poll question, that's also how you can engage in those poll questions. So let's go ahead and really meet today's speakers and the experts, if we could. I'm really excited to spend some time with both Chad, Ryan, as well as Stephen. These three individuals are really experts in their field, and what we're going to ask them to do is really allocate that expertise in three different vantage points. So first of all, let me say welcome to Chad. Chad, are you out there? Can you say hello?
Yeah. Hey, Michael. How's it going?
Yeah, it's great, Chad. I'm really going to ask your expertise that has really a career's worth of expertise in this particular field to represent and advocate for the trends of the field and advocate for the needs of the particular customers. So I'm really excited to kind of hear your voice throughout today's call. And just so everybody knows, where are you calling in from?
I'm in beautiful Houston, Texas.
Oh, well, welcome. So glad you're here. Thanks, Chad. Looking forward to your comments. And next we have Ryan. Ryan leads the fire and life safety team at Everon. And really, that's a technical team of resources that really have deep-rooted knowledge of both about the codes, the operational expertise, and really the standards of fire and life safety. So, Ryan, certainly want to hear your voice and welcome you to today's call. Welcome, Ryan.
Hey, thanks, Michael. Calling in today from Boca Raton, Florida, our corporate office. So really excited to dive into the battery energy storage market.
Oh, fantastic. Love hearing your voice. Looking forward to your contributions, Ryan. And last but not least, we obviously have Stephen Joseph. Stephen really has subject matter expertise in some of the new and emerging advanced detection solutions. Some of these are really lesser known than many on the call. Certainly want to welcome your voice, Stephen. Welcome to the call.
Well, thank you, Michael. Glad to be here and happy to participate. I'm calling in from sunny Portland, Oregon. It's rare that I get to say that this time of year, but
yeah, love it. We got some anchors all around the country. That's always cool. I think we literally have all corners of today's call covered. So that's awesome. Well, guys, let's go ahead and jump right in. If we could just talk a little bit about the agenda. In short, what you're seeing on the screen are three main topics, but let's be fair to what I said earlier, that this is kind of a new and emerging topic. There's a lot of different knowledge bases represented on today's call. So Chad, just from your perspective, I guess if you had to simplify, what does a good webinar look like in your words today?
Yeah, I mean, I think it's kind of showing very quickly why we're here, why the BESS market is exploding. No pun intended there. And then really working through the unique fire hazards. Some people may have a lot of experience with that. Others may be relatively new to those unique hazards. And then really trying to get to what can we actually do about this? And why are we where we're at today? And what does that look like in the future in terms of really fire prevention?
Yeah, I love it. I mean, best case scenario, we're getting so far out in front of this. no facilities are lost, and even worse, right? So that's really why we're here. But let's maybe jump into that opportunity if we could, and let's start there, because I think the notes that I took coming into today's call is that this is in fact a very new industry. I think when we think about commercial BESS, it's really less than 10 years old. And I think that the market is actually exploding, or growing, I think is the words that you were using or meant to use there, Chad. So maybe you could make these two slides easy. What are we looking at, and what should we take away from this information?
Yeah, I mean, I think that the BESS market is really, that the growth in the BESS market is why we're here. But, 10 years ago, the BESS kind of mix in our nation's electrical output was very, very small. So it just was kind of inconsequential. If you look at that left slide, the projected 2024, so the first gray bar is the installed battery capacity expected in the year of 2024. We'll see where we get, but in essence, that 2024 bar is just about as big as all of the previous bars combined. So in 2024, the BESS market may double in size compared to previous years. And, that type of growth means there's more of these facilities sitting around the United States. You can see the chart on the right is future and current BESS facilities, and lots in Texas, lots in California, but they're literally going in everywhere and anywhere with electrical utilities and private consumers or businesses. And so that type of it's just math, like that many types of facilities out there, that many of them around, you start to see problems that happen in the news. That's the news, that you have a fire and you see it because there's more of them out there. And so we get some interest in it because of that. So, I mean, we're here because that, like you said, the industry is new. It's growing like crazy, and there are hazards that, that are out there that aren't completely comprehended yet from a regulatory perspective. And so in the lack of that vacuum, we have to find opportunities to mitigate those risks.
Yeah, that's really provocative. First of all, I mean, it makes intellectual sense just from a lay perspective, the importance of cleaner energy and the growth that you're seeing that you mentioned. What was really surprising in some of your research that you're presenting is I thought maybe out west would be where you would see a lot of these facilities for maybe some of the obvious reasons, but you start to see the growth really all across the country. And that was what was so impressive as you were commenting and making this information come to life. Really provocative information. So maybe we can transition over to you, Stephen, and let's talk a little bit more specifically about fire, because this is a new area. I mean, this might be obvious to some, certainly brand new to others, because when I was seeing this topic, I thought a fire is a fire is a fire. And I suspect that is not the case. So isn't a fire always a fire, Stephen? How would you explain that in a simple way?
Well, yeah, I mean, Michael, the short answer is no. I mean, you get different problems when different things catch fire. And as we're talking specifically about lithium-ion chemistries, BESS fires are unique in that once thermal runaway begins, there's really no effective way of stopping it altogether other than, controlling propagation, which is, what we refer to in this slide as containment. Walking through the anatomy of a fire, BESS fire, we start with what's referred to as, of course, stepping through the stages. Stage one, which is referred to as the abuse stage. And that's where some anomaly involves a cell or a group of battery cells, and ultimately leading to stage two, the onset stage, where cells begin exhibiting an exothermic reaction, ultimately leading to the thermal runaway stage, which is stage three. And so, people oftentimes ask, what is the time it takes to go from stage one to stage two? Well, it could be a matter of milliseconds, such as a puncture or something to that extent, to a matter of days, weeks, or months, depending on, the source involving the fire, perhaps, or, the potential for fire. So, just considering the nature of the abuse, we get to stage two and stage three, and that happens relatively fast. Once thermal runaway begins, propagation can only be relatively fast. So the point here, it's important to focus on preventative efforts and shift that discussion away from containment. Obviously, containment's important if we get to that stage, but obviously, if we can prevent it, let's prevent it. So prevention early on is really the key focus of where we're trying to go with this.
You know, what's interesting about the way you kind of walk through those stages, two things kind of jumped out at me, Stephen, as you're talking about it. One, four very distinct elements of that stage, but two, the timing of it. It could be very, very quick. It's not like an elongated process. And maybe a bit of a foreshadowing. I think when I see that prevention and containment arrow on the slide, that probably opens up maybe some different mitigation strategies that I suspect you might want to circle back to when we start thinking about how we can intervene and disrupt these stages of this fire. So really, really interesting. And any additional comments that you want to make, Stephen, before we transition?
I guess just to put it in terms of, you think about, hangars, for instance, we talk about very early warning and the need for very early warning and the nature of, say, an event such as JP4 jet fuel catches fire, it's going to be almost instantaneous. So I point out that just from the perspective that we don't want to get to that stage if we can detect early enough the scenarios that might lead to, say, the abuse factor of energy storage failure or battery failure. That's again, just reiterate the key point here is we want to be at that particular stage detecting the abuse factors, and we'll talk a little bit more about that.
Yeah, for sure, Stephen. Just a little bit of lighthearted humor here. I was talking with Chad in preparation for today's webinar, and I'm based out of Chicago. There's a series called Chicago Fire, and one of these episodes was talking about an electric car fire and the batteries that caught fire. And literally, they were pointing out even the mitigation strategies on network television are fundamentally different. You would think that the fire department here in Chicago just simply douses that car fire with water. And it was calling out that, hey, a fire is not a fire. They're all a little bit different, and the approach to mitigation is really good. So again, being the non-technical expert on today's call, I thought that was really appropriate to today's call for sure. Really understanding the anatomy of that fire. Really interesting stuff. Great contribution, Stephen. So maybe we can flip over to some of the consequences, and I think we'll probably hear from a couple of different folks. Let me first start with you, Chad. When we start digging into this, and you are hearing from your customers, and customers could be a pretty big word to use. What are some of the highlights here? What should we be thinking about in terms of some of these risks?
Yeah, it's interesting because when we started, I don't know what, 4 years ago, Ryan, talking to people about battery energy storage, we were really focused on what does the code require. So just put in whatever fire system the code requires, and we'll get into the nuances of that later. But as you really start to think about this from a risk perspective in terms of being the owner or the fire department tasked with responding, or even the community, a lot of other scenarios come up, right? And in the fires that we've seen so far, where they burn for a very long time, sometimes we get obviously the concern from injuries to folks that may be on site in the event that something does catch on fire and there's an explosion or something that requires venting. But you've also seen first responders being injured as they try to respond based on maybe the different chemistries that they may not be completely familiar with or other factors. There's obviously, as an owner, a financial loss or downtime. One of the things that we've learned over the last year as the Inflation Reduction Act has kind of turbocharged this industry is that there's also insurance risk. And there's a very good case for using some of the advanced detection and prevention solutions that we've been working with clients with from an insurance perspective. That's something we had no real comprehension of in the beginning. And also just more and more of these are starting to be insured. The other thing that I don't think anyone foresaw or very few foresaw was community resistance. As these things get built more and more and more, and you see the fires, the number of fires per installed capacity is going down. We're just installing so many more that we just naturally get more and more fires. You get a lot of concerns about, hey, this giant battery is on fire and it's putting something in the air. I want to understand what that is if that's near my house. There was actually a project out here in Katy, Texas recently that was just foregone, canceled because of community concerns. And so it's just really, and then you start putting water on a fire like this. Well, what are the metals? It's lithium. What are the metals that are going into the stormwater collection systems or potentially into your groundwater? So I think that's a really interesting way to look at it through a risk lens. And I think depending on who you are in this ecosystem, each one of those may speak more or less to you. But it is something that we're seeing a lot more interest in terms of creating a use case or a business case for some of these advanced detection and prevention solutions.
Hey, great comments there, Chad. What I thought maybe we could do is let's see if we could engage the audience around kind of some of their perspective first. So if we could, let's see if we can inject a poll here, and then we'll come back to this exact same slide. Ryan, I'd like to kind of pick up some of your comments on some of those quotes. So I think you're seeing a poll right now that says, what consequences from a BESS fire is your primary concern? It could either be your concern or your client's concern in the event that you're in a service space. And I think there were 4 topics that were captured here. Could be financial or downtime, lost productivity, obviously injuries, loss of life or risk, community impact, or maybe there's something else. But I think this could kind of shape maybe how you are thinking about this. So if you'd be so kind to go ahead and just grab that poll, go ahead and submit your answer. We'll think about that. I think you just go ahead and just click that little radial button and then you hit submit. So this should be pretty straightforward. Again, if you're looking for the chat or the Q&A feature, all of those little tabs should be part of this webinar interface. They should be obviously labeled the same way, chat or Q&A. Not only can you interact with the poll in this way, you can also go ahead and submit a question. Some of those questions come to me directly. Some of those questions come up more broadly. Either way, there's really a terrific opportunity for you to engage both Ryan, Stephen, and Chad directly, and we'll try to get to all of those questions throughout. So again, thank you for any answer to that poll, as well as any questions throughout. So I think when I see some of these responses, and I think just topically, it looks like kind of the downtime or the financial one, Ryan, really kind of jumped out at the highest. But as you can imagine, there was a varied response, right? There was, injuries. I guess number 2 was the community impact. So maybe some of that maybe speaks to the environmental element. So like downtime financial was clearly number 1. Community impact was probably a distant number 2. And not to minimize the importance of injuries, I just think, the number of injuries are somewhat smaller versus maybe the before 2. So if we could, maybe we bring that original slide back that talked about some of the impact and risk. And Ryan, maybe you could comment on some of these, because I think you heard some really good examples, not only from our audience but also from Chad that were teased up.
Yeah, no, I think it's a great discussion. You're seeing around the country, from the Society of Fire Protection Engineers, the Automatic Fire Alarm Association, NFPA, and other organizations that are really, leaning in to battery energy storage systems, finding fire detection solutions, fire protection solutions, and so forth. And it was interesting to see the response in the poll questions. Life safety, while it's definitely top of mind for everybody, in these particular applications with battery energy storage, most of the time we've seen them be in rural areas, and farther away from buildings and building occupants and so forth. So we're seeing less injuries, although case in point with the surprise fire, which really opened our eyes as an industry to the threat or risk to first responders and to firefighters coming into these applications. Really, the financial impact is the greatest impact from the large battery energy storage providers and really all key stakeholders within the industry. So the downtime and loss of use of the systems plays a significant role in how we look at protecting these facilities, as well as the community piece. The community piece is probably just as important to the financial and downtime piece because we're seeing in pockets around the country where communities are pushing back, saying not in my backyard or not in my neighborhood, right? And there's been some significant fires most recently in 2024 in areas or pockets around the country like San Diego, like in Illinois and Texas and other places around the country where these systems are being pushed more to urban areas, more densely populated areas. The size of the systems are becoming smaller, which allows them to be more more impactful in dense communities for supplementing the power grid or providing supplemental power to large facilities like hospitals, distribution centers, or warehouses, things of that nature. So we are seeing that the battery energy storage systems are being smaller in size, more densely populated areas, and they're being pushed into in-building applications or in structure applications. And this is really leading for us to drive for more detection technology, better detection technology. And as Steve and Chad rightly pointed out, and you brought up, Michael, is getting to that prevention stage. I don't know if we'll ever fully get to 100% prevention, but at the critical point of the abuse factor, we have to have more technology, more solutions around that mitigation and prevention piece.
Ryan, when I was thinking about this, and I'm gonna bring in Steven to see if he has some additional comments to make, is the different vantage points. I mean, you talked about the impact to the local and immediate business, and then you have the impact to the employees, but then you also have the impact to the community, even a region that could be impacted. And so the risk is quite frankly shared from a very large audience from that perspective. Steven, anything that you want to comment on that you've heard in this discussion?
Well, I just say also, consider reputation. And there's obviously that portion of business that, often is maybe underlooked, but often very important to the stakeholders. And I just say, more often jurisdictions, are imposing stricter compliance, going beyond that let it burn strategy. And, just navigating through prescriptive or imposed requirements is not always a cut and dry, obvious solution. So nor are the technology solutions well understood, especially as new technologies evolve. And consider it evolving faster than code cycles occur, which is typically every 3 years. So, you look at that scenario, and of course, there has to be a better understanding of those technologies that are available and how they can be prevented. These situations can be prevented.
So let's talk about that code if we could. Ryan, maybe I start with you. I think maybe all of us might or others might have some comments to make here. But the way I understand, fire and sprinkler, it's very code driven. So when you think about managing these fires risk, isn't there a national standard? I guess where are we on that one, and how should I be thinking about that?
Sure, sure. Over the years, we've always relied on NFPA and the International Building Code to really set the code requirements and the installation requirements. So you think about the International Building Code and the International Fire Code as really what drives our life safety requirements. And then you have the NFPA installation requirements of NFPA 72 and other documents that have really led in in the fire alarm world and even in our sprinkler world as well. NFPA has done a tremendous job of leaning into the community and to the application and developing a standard known as NFPA 855, which most recently came about over the last couple of years and was really needed for the industry as a whole to have some sort of standardization of what are the requirements and what are the applications or where we need a standard. And so if you break it down from the national level to each individual states, you're going to have a continuation of stricter requirements or even in some cases more lax requirements, dependent upon where you're at in the country. Very much like our life safety codes and requirements, dependent on the jurisdiction and their experience and their risk associated with battery energy storage is going to lead to maybe even stricter requirements. San Diego, for example, has a meeting today where they're asking, they have community outreach and they're asking for the community to come in and tell them how they feel about battery energy storage, how they feel that a fire event, how it would impact their community, their residents. Most recently, San Diego this year had two individual fires, one in the northern part of the county where they had experienced fires previously, and then one in the southern part of the county. Two very different types of applications with battery energy storage, but the impact to the community was significant in both cases. In one event, you had a full evacuation of the community around it and the schools around it based off of air quality and what they believe to be hazards in the air relative to the materials burning. And then in the second application, you had a structure fire with a battery energy storage and fire inside of it, which became a difficult proposition for first responders to fight the fires, which led to a prolonged fire event with a significant amount of water and damage to the site and the surrounding areas, but then also led to the event reigniting and continuing the event for several days onto over a week or so. So in these local jurisdictions that have had the experience of dealing with battery energy storage fires, we're seeing pushback from the communities, pushback from the AHJs, and really a push or a need for more regulation, the first thing, and then more solutions on prevention, mitigation, detection, and protection is really what we see in the code community.
Yeah, Ryan, I'm glad you pulled in some of the local examples because I did make note that you were from San Diego, and oftentimes you're hearing from the West Coast that's really kind of out in front of some of these comments. Really insightful things, and I even like some of the headlines that you're grabbing here on this particular side. Stephen, from your perspective, I mean, do you have anything to add in terms of some of the local code development? Anything substantively different maybe from your state and that's complementary to what Ryan said?
Yeah, no, I think it's all about that. I mean, the states are taking, local jurisdictions are taking more of a stance in terms of, in ensuring that there is a higher level of, protection levels than perhaps what prescriptive measures require. And so, to that extent, it's very similar here in Oregon. And we're seeing that across the country, quite frankly.
Yeah, no, I agree. Like I even saw that one as soon as you were talking about San Diego, I thought all of these were California, Ryan, and then I see the New York headline, and I'm like, all right, I don't see Chicago represented there, so maybe I got to do my part and kind of help the cause here a little bit locally. Chad, anything from your perspective that you're hearing? Is there an awareness and an appetite, maybe from the customer standpoint, around local code development? Do they look for their partners and integrators to keep them current? I guess where does the customer land in all of this?
Yeah, I guess I would say it depends. And it depends on, I guess, two main factors: how sophisticated the local regulatory regime is, and the the level of experience our clients have with this kind of application. And so now we have some customers that tell us, please, let's partner on this and we'll work together on the requirements with the authority having jurisdiction, and others, have that relationship well handled. So it depends. And if it's all right, I'm gonna go back to the kind of local code development. I think what's really interesting is you see a completely disparate set of requirements after NFPA 855. So what a county in California may ask for could be entirely different than in Texas where I am. But I think the point Stephen made earlier was really important, in that most of the AHJs we interact with are generally asking for more than just 855, or NFPA 72 code compliant systems. What the extra is kind of depends, right? Sometimes it's a water tank, sometimes it's flame detection. We'll talk about all that stuff later, but I think that's what's very interesting today as the national standard evolves. We may get more clarity on that, but to Ryan's point, I think there will always be opportunity for kind of performance-based solutions, and without that national standard kind of variance in what each local AHJ requires.
And
Yeah,
I would only add to that, Michael, is, the one thing that we as an industry want to make sure that we stay ahead of is, at one point, in response to the fires that San Diego had experienced in the battery energy storage space, they had enacted a bill to put a moratorium on all battery energy storage construction. And that was back in September, I believe, of this year. Subsequently, that moratorium did not pass. But we could, as we look at the impact to communities and into our industry, we have to be very mindful of the fact, if we can't find a solution to the risk and be able to mitigate and prevent that risk, we're gonna have communities push back and push for more moratoriums, which will, in turn, inhibit our ability to invest in this great technology.
No, really good points, Ryan. I mean, that's kind of where my head was going as you guys were describing. I think even Dean, who's one of our participants, really kind of called out 855 and 72 are really the only real standards to kind of help provide some direction. But as you think about where there are some standards, where there should be some standards, then you start to factor in where can you get the best ROI in mitigating some of the before mentioned risks that all of you talked about. The production, the financial, the reputational loss. I think, Stephen, that you called out, obviously the life prevention piece as well. So some really provocative things here. So maybe before we start to officially transition into methodology, we could just maybe start with an open discussion with you, Stephen, and just think about, as we transition to fire protection methodology, can you tell me about how fire systems work today to prevent fires at BESS facilities? And then we can kind of maybe go a little bit deeper.
Sure. So as the first line of defense, early detection is, as I pointed out, crucial. So when appropriate technologies are applied and properly installed and commissioned, advanced detection technologies are intended to detect those anomalies at the early stages of development, obviously with the intent of mitigating the propagation and ultimately consequences, largely by signaling personnel and automation systems at the right time. But I remember, a lot of these sites are unmanned, so it's really that automated detection technology that's being relied upon to take some form of action to help mitigate that, again, that propagation and the progression of the event. So unfortunately, we often see reactive technologies applied, or in some cases, no detection at all. That let it burn mentality. We've done our UL 9540 test, and our systems are safe, but yet those systems are catching fire. So we see that regardless, and the reactive technologies just aren't enough. I mean, again, at that containment stage, it's maybe too late. So really got to focus back on that early detection piece and applying the right technologies, integrating those technologies appropriately with the management systems as well as the fire alarm signaling systems as required by codes and standards. And that's kind of the basis of that.
So I want to follow back up with you, Stephen, in just a second about really some of the advanced detection and preventing some of these BESS fires. But you kind of brought back, step one, or how it's represented on this slide. I want to bring Ryan in here around NFPA 855. Is there anything that you can share in terms of the future of NFPA 855? Is there an update that you're aware of? Anything that you want to predict here?
Yeah, well, let's just be clear. I don't want to predict anything about where the codes are going to deliver, but I would say that the technical committee that NFPA has established for NFPA 855 is a terrific group of individuals that have done a great job of bringing a standard to market that the industry can lean on as its basis of design and protection of battery energy storage systems. And if all NFPA documents go through what a 3-year code cycle. So we're just in the first year of the most recent edition of the code cycle, and so you can see subsequent enhancements coming in over the next 3 years for NFPA 855. And the technical committees meet, on a monthly basis sometimes, and sometimes on a more frequent basis based off of task groups and working groups. So what I would say is today of what we see of NFPA 855 is a great foundation, but we're definitely pushing the technical committees and NFPA and the community to go farther. And we haven't completely eliminated the threat or risk. I'm not sure we ever will. However, we have a unique opportunity to continue to get better from that perspective. And the way we're going to do that as an industry is providing more solutions around prevention and mitigation. So what I would say is that the technical committees are continuing to understand that we have to have more technology around identifying the abuse factors that contribute to a thermal runaway event. And the UL 9540A listing has done a good job of putting the standard for battery energy storage systems. But then we need to continue to enhance those standards for containment and mitigating or preventing propagation of the event down to the cell level. So there is even some new advanced technology that's going to push for controls and technology around managing the energy and the charging and the storage at the cell level. And that's really where we get down to it. Today, we don't have the ability to control how these systems interact with the battery management systems down to the very individual cell level. And so as that technology becomes further, as our codes and standards become further, I think you're going to see that this industry continue to thrive and be able to produce a product that is safe, and that delivers a solution to the market that we're all looking for.
So I did want to call out two specific questions that I'm pulling off some of the interaction I'm getting with some of the participants. I believe you may have touched some of this already, Ryan, but just so I ask the direct question that I'm seeing here, what are you seeing AHAs asking the most regarding for fire systems and BESS? I think you touched on it a little bit, but I just want to ask that very specific question. Do you get anything, regularly from AHJs when it comes to BESS solutions?
It's kind of hit or miss. So California is probably the most regulated, I would say, as to the requirements for battery energy storage systems or energy storage systems in general. But around the country, we're seeing a push for more detection. Traditionally, in most certainly in the rural applications, the fire departments and the local HJs are requiring some form of detection. They usually fall back on a technology like flame detection or something similar to that, where an event has occurred and they want to be able to be notified that event has occurred. Primarily because most of the battery energy storage systems in these containerized applications don't have a lot of technology for detection or prevention that come to us from the manufacturers.
Hmm.
So in those cases, the fire departments want to be notified of an event, and they usually fall back to some type of flame detection. In some jurisdictions, they are going beyond flame detection with more what I would consider, say, a performance-based solution in technology like thermal imaging cameras. Thermal imaging cameras, currently today, there is not a NERDL listing, nationally recognized testing laboratory listing like Underwriter Laboratory or FM for thermal imaging for the use of fire detection. But we're starting to see manufacturers, we're starting to see the regulatory industry and the HJ community push, and even the engineering community to push for these technologies to be a standard solution on these sites. So I would say that across the nation, we're seeing AHJ's push for flame detection, thermal imaging, and then the jurisdictions that have really been impacted by fires have, experienced, community damage or risk or even firefighter injuries. First responder energies, they're pushing for more detection technology and prevention technology within the containers themselves. So it really is kind of hit or miss as you go across the country.
Yeah, good perspective. Stephen, I do want to go back to the anatomy of the BESS fire, but before I do that, because I want to continue around some of the advanced detection solutions. So, but before I throw it over to Stephen, Chad, I just wanted to acknowledge, I think, a follow-up question around risk that I didn't know if you had any additional perspective that you want to share. There was a question that came in around the downwind risk to the population when there's a BESS fire. I know there were some great comments in the chat. Is there any additional context that you wanted to add to that?
Yeah, little known fact, I actually was educated as an environmental engineer, so I may actually be qualified to answer this question. So, I mean, the risks really are, it's that not in my backyard mentality, belief, whatever you want to call it. Something catches on fire, and naturally, if you live near it, you want to know what's in those emissions. Here in Houston, Texas, full of chemical plants, similar concerns. If there's a industrial fire, people want to know if that's blowing across my property, what's in that, right? And the same unique battery chemistries that make the fires themselves unique also create some unique air pollution scenarios. And so, part of that community resistance that we've seen is people rightfully wanting to understand that, hey, if this thing is half a mile from my house and catches on fire, what's going to be in the air that, me and my family are breathing. And so we've seen developers having to kind of go through as part of the, community open comment period and answering questions like that. Like, what is the battery chemistry? If it catches on fire, what are the pollutants that are in the air? So just another risk that we need to consider.
No, I appreciate the follow-up there, Chad. Thanks a lot. So Stephen, let's kind of bring it back to this slide that I think you talked about already in terms of the anatomy of the fire, but maybe we can open up with some of your comments around just some of the advanced detection, measures. Do we have technology that can help us today? And what I'll ask is maybe just for your initial opening comments, because then we can maybe engage the group with another poll and then kind of come back to you. So just any opening comments that you'd like to serve up.
Yeah, so I mean, just coming back to the stage one, because again, that's our best opportunity to detect things at the earliest stages possible. And fortunately, there are those technologies that are designed to work in that abuse stage of battery failures. And remember, it's not necessarily the battery failing itself, it might be the surrounding environment that's involving the battery. And so it's back to the whole JP4 jet fuel example that I gave for a hangar. I mean, if you know it's flammable, you take a match to it. If we know that these things, if they catch fire, they're going to burn and they're not going to be able to put them out. So if we could focus on that stage one development and find technologies or apply technologies that are appropriately designed to detect those abuses. So when we talk about the abuses, consider cases of abuse which can include, thermal, mechanical, electrical factors. And so focusing on advanced detection technologies to detect such anomalies, we prioritize our prevention, turning what would have been a firefighting exercise into nothing more than potentially a maintenance exercise if we have that opportunity. And that's really the key message here is having that opportunity by use of detection technologies to avoid involving the batteries in some form of abuse factor that would cause them to, have that onset and lead up into that thermal runaway stage.
So really great insight, Stephen. Let's go ahead and see what the group has to say from an audience standpoint. I think this is our final poll question, everybody. So if we can do this correctly, I think the second poll just came up on your screen, and it said, have you considered any of the following options for advanced prevention or detection? And there's really kind of 4 key areas that were highlighted. Detection of abuse on batteries or subsystems. I think Stephen was just kind of calling that one out. There's a couple of examples that are shared there. There's advanced detection sensors. There's some really specific technologies in off-gas or VOCs. There's some terrific imaging solutions. So again, you're seeing different modes for data capture, like flame detection or thermal cameras. There's some really provocative ideas and solutions in that space. And then even use of traditional solutions. Sometimes you get a terrific ROI around, maximizing what you might already have in play. And how do we create a more progressive approach in thinking through how we might want to use fire or smoke detectors. So a couple of different options there. Feel free. In Chicago, we say vote early, vote often. Go ahead and do that, whatever you like. That would be great. It looks like we have quite a few responses already. They're continuing to come in, which is really cool. I would also put a plug in for any additional questions that you'd like to have answered. We're running down the final 10 minutes of our call here. So if you have a question, I'd love for you to go ahead and get that submitted so we can answer it in real time. You go ahead and do that by either the chat or the Q&A toggle that is on your screen. So let's go ahead and publish the results if we could. And then, Stephen, I'll throw it back to you to see if you have any response or comments on what you're seeing in some of these results. And if you go into the chat, Stephen, I think you'll be able to see it in real time. The clubhouse leader is advanced detection sensors, so off-gas and VOC. So maybe you could just simplify that for those of us that might not be as familiar with that, just to provide a bit of context around the value of that. And then the second key area is imaging solutions, specifically flame detection and thermal cameras. Maybe if you could just put some comments there, and if you finish, I'll throw it over to Ryan to see if he has anything to add, and we'll go from there. Stephen?
Yeah, you bet. Thanks. When we think about that abuse stage, stage one, I mean, consider temperature, humidity, water ingress, mechanical impact, thermal events from support systems, even the air quality, such as dust or, corrosive gases, from external sources. We'd like to think these things are well sealed, but there's always some form of leakage. So you think about sources which can affect charging and other control systems that manage the batteries. So, it's really, as the polls are showing here, advanced detection technologies that in this stage of development include, sensors such as mechanical sensors for the detection of impact, temperature, thermal imaging detectors to detect thermal anomalies at the point of interest, and humidity detectors, which are typically integrated as part of the battery management system. And then also water leak detector. Something as simple as a water leak detector could have prevented, a known fire that occurred. It's relatively inexpensive technology, but very effective in the respect that, here we have, a situation that's surrounding the battery that involved the battery, and it could have been avoided with something as simple as a water leak detector. And then also, gas detectors such as SO2 for the corrosive gases, air quality monitors for dust, and of course, very early warning smoke detectors to detect the issues before the fires progress. Again, as I said, as the cells fail, they create this exothermic reaction, which is, begins the stage 2 process. And then as you have these elevated temperatures, cells obviously will begin to swell and ultimately vent gases. And those gases are detectable using gas detection technologies specific to the vent gases that are present. And from our experience in education and research that surrounding battery energy fires, VOC sensors are ideal at this stage as they can detect, a host of gases relevant to the gases typically present during the stage of development. And then, we talk about those very early warning smoke detectors. They're also ideal at this stage of development because, we think about that exothermic reaction, things are heating up and smoke particulate is being generated at the incipient stages as a result of that exothermic reaction, heating up materials such as sleeves housing the cells, plastics, and so forth. These can be detected by those incipient smoke detectors, often buying time to initiate automatic shutdown, disconnect power sources via the battery management system. So it's all about management in that respect. And then go ahead.
Steven, I'm just struck at how big that list of solutions really are. What an impressive group of a list. But you were going to add something else. Please go ahead.
Well, I was just going to continue down the stages of development because you have different technologies that are aligned with the stages of development, and so we talked about that prevention stage, right? The technologies that could be applied in the preventative stages to never get to that thermal runaway event or shut things down before it does. But if it does reach that thermal runaway stage, we need that containment portion, right? We need that protection level that, upon reaching the thermal runaway, we got to have listed fire detection technologies such as a listed smoke detector and or, listed radiant energy heat detectors. And those technologies are generally intended to initiate suppression systems where present early on to help mitigate the propagation, of course, that cooling effect to slow down the propagation. And that's the really the role of suppression at that particular stage. But as the condition progresses, the fire potentially risks explosion to the present from combustible gas formation. So again, in absence of combustible gas detectors such as H2 to control ventilation as part of the defibrilation system, we got to be ensured that gas concentrations are below explosive limits in accordance with prescribed criteria.
Really eye-opening. I didn't know all of those solutions were really available for all of those different reasons. Ryan, anything that you wanted to comment on? And I would just draw some attention to a comment that I think Chad made, that he was reflecting on how some clients are really asking for some of these solutions inside the BESS containers themselves. So Ryan, anything that you'd like to add?
No, I think the only thing that I would add to it is Steve did a very good job of laying out the different technologies that we could use to identify a possible threat or an abuse factor leading to, the thermal runaway event itself. But I think the overreaching message that Chad's hit on and that Steve's done a great job to be able to conceptualize for us is that it's not one approach, it's a holistic approach. Very much we in the life safety industry, we get focused on how do we address one key factor. And with battery energy storage systems or energy storage systems themselves, we really do have to take a holistic approach, providing environmental sensors, gas sensors, abuse factor sensors, thermal and flame detectors, and as Steve rightly mentioned, bringing suppression and protection into the solution as well to mitigate any external factors that could lead to the degradation of the cell or the module and lead to a thermal runaway event.
Hey guys, really great comments. What I've been doing as you guys have been adding some of your thoughts is taking a good look at the Q&A and some of the chats. Really appreciate those that have participated throughout today's call. What I wanted to do was also create a way for anybody that is either on today's call or listening to this recording on how to get in touch with Chad, Stephen, or Ryan. You should be seeing on the slide all of their contact information. You can go ahead and just submit those questions direct, and regardless of whether they're in the best position to answer that, they can kind of help orchestrate who could get involved with finding a solution to any question or need that you might have. I think we only have maybe 2 or 3 minutes left. Chad, let me just kind of go around the horn and see if you have any closing remarks, and I'd ask you to keep it real tight because we only have about 2 or 3 minutes left. So Chad, your closing comments?
Yeah, I mean, I've really enjoyed this. I think what I would highlight is we at Everon really enjoy working in this space and finding solutions that help every client mitigate the risks that are of concern to them, code-based or performance-based or both. I love getting to do that kind of under our one ideal partner.
Yeah, I love it. Same question for you, Stephen. Anything that you'd like to leave the group with? I think you might need to unmute there, Stephen. Thank you.
Thanks for that. No, I echo Chad in that, I appreciate the conversation, enjoyed it, and look forward to further conversations.
And then Ryan, I'll throw it to you for the final word. But before I do, I would just call everybody's attention to everonsolutions.com. There's a terrific link for additional resources on the fire and life safety team, specific verticals, specific ways that you can kind of engage our subject matter experts at Everon. I would also call maybe a screenshot of Chad, Stephen, and Ryan's contact information. And I would thank everybody for jumping on. But Ryan, why don't you kind of bring us home? Any closing remarks that you'd like to say before we wrap up today's call?
Michael, you did a tremendous job as our leader today, so thank you very much. You always do a tremendous job leading the presentations, and I would just share that Chad and Steve, you really hammered home the fact that there's a significant amount of need and risk associated in energy storage systems. We've been fortunate, Everon as a team and the National Fire Life Safety Team have been fortunate to participate in energy storage projects throughout the country, both at every stage from design and planning to development and execution and delivering solutions both on the detection side and on the prevention side. So I'd just like to say that we're going to continue to push our code community partners to further the NFPA standards, the International Building Code standards, and International Fire Code standards, and work with our local authorities having jurisdiction to help support them in their communities to be able to deliver energy storage systems safely and mitigate the risk as best as possible.
Well stated, Ryan. Stephen, Chad, Ryan, thanks for your guys' participation today, and thanks to everybody that jumped in. You guys have a great rest of the day. Thanks, everybody.